So welcome back to my video lecture 9 on P block elements. Okay, so hope you have watched my the last video, that is video lecture 8, isn't it, wherein we discussed about borax B test and also orthoboric acid, that is H3BO3. Still we couldn't complete boric acid, isn't it? Okay, we studied only its preparation, we studied only its physical properties. Okay, what did we learn in physical properties, students? Okay, yeah, what did we learn in physical properties? In physical properties we understood that boric acid is a Lewis acid but not an Arrhenius acid. Okay, Lewis, and it acts as it is a weak acid, and it is a monobasic acid. Monobasic acid, even though it has 3 hydrogens, it will not release all the 3 hydrogens when it is dissolved in water. It will release only one H plus ion when dissolved in water. That is why it is going to be a monobasic acid. And moreover, which H plus ion will it release? It will release the H plus ion of water, but it will not release its H plus ion. Therefore it is not an Arrhenius acid, it is a Lewis acid. It's a Lewis acid. Understood? Okay, now let us understand the heating of boric acid. Okay, yes, yeah, heating of boric acid. Heating of boric acid. Okay, yes, heating of boric acid. Okay, well, we know what is the formula for boric acid. It is H3BO3. This is correct. Okay, what happens when boric acid is heated? Yes, at 100 degrees centigrade. Okay, when boric acid is heated at 100 degrees centigrade, it's going to form HbO2. Okay, when boric acid is heated at 100 degrees centigrade, it's going to form what? HbO2. When HbO2, what is this HbO2? This is called as metaboric acid. What is it called as? This is called as metaboric acid. Understood? Okay, so when boric acid is heated at 100 degrees centigrade, it's going to form metaboric acid. When metaboric acid is treated with water and heated at 160 degrees centigrade, okay, when metaboric acid is treated with water and heated at 160 degrees centigrade, it's going to form what? It will form H2B4O7. H2B4O7. This is called as tetraboric acid. What is this called as? Tetraboric acid. Understood? Okay, so when metaboric acid is heated with water at 100 degrees centigrade, okay, it's going to form H2B4O7. What is H2B4O7? H2B4O7 is called as what? Tetraboric acid. When tetraboric acid is heated, it will form B2O3. What is B2O3? This is boric anhydride. Okay, this is called as boric anhydride. Understood? Okay, so come again. Okay, boric acid, when it is heated, it will form metaboric acid. When metaboric acid is heated with water, it will form tetraboric acid. When tetraboric acid is further heated, it will form what? Boric anhydride. So please remember the heating of boric acid. Heating of boric acid. Understood? Okay, are we clear? Yes. Now let us understand the structure of boric acid. Very important. Okay, the structure of boric acid. Okay, structure of boric acid. Okay, that is H3BO3. Structure of boric acid. Look here. Okay, see, boric acid, it has got a planar layered structure. Planar layered structure. Okay, it has got a planar layered structure. Since it has got planar layered structure like graphite, like what? Graphite. Okay, it has got a planar layered structure like graphite. Since it has got a planar layered structure like graphite, okay, it is slippery. Okay, it is what? Slippery. Slippery. Okay, understood? Yeah. Okay, what is the structure of boric acid? It's a planar layered structure like graphite, therefore it is what? Slippery. It is slippery. Okay, understood? See the structure of boric acid. Yeah, each boron, okay, is surrounded by 3 hydroxyl groups like this. Okay, OH, okay, OH and OH. Are you getting my point? Okay, this is one boric acid. Okay, see the 3-dimensional arrangement of boric acid here. Okay, this is one boric acid. Now another boric acid, just like it goes like this. Okay, wherein I can write what? B, yes, then what? Okay, OH, or else B, O, yes, H, BOH, okay, yes, OH and OH. This is another boric acid. Like that, you can write any number of boric acid molecules here. Okay, B, yes, O, B, O, H, okay, OH, and then what? O, yes, H, BOH. Like that, we'll have what? B, okay, then OH, yeah, okay, then OH, and then what? OH. This is another boric acid. Okay, what they're going to form? Okay, all the boric acid molecules are held together by what? Okay, all the boric acid molecules are held together by hydrogen bonds. Okay, the boric acid molecules are held together by what? Hydrogen bond. Look here. Okay, don't you think there is a hydrogen bond here? Yes, there is a hydrogen bond here. If I write it like this, don't you think there is a hydrogen bond here? Yes, there is a hydrogen bond. Okay, look at here. Okay, see this. See this. Okay, there is a hydrogen bond here. Yes, there is a hydrogen bond here. Okay, and then what? If I write it like this, there is a hydrogen bond here, isn't it? So like this, so there is a hydrogen bond here. Okay, so they form a 3-dimensional network like structure. They form a 3-dimensional network like structure. Okay, and okay, all the boric acid molecules will lie in one plane. Okay, one plane, there will be one more plane, one more plane, one more plane of boric acid, one more plane of boric acid. So all the boric acid molecules will be arranged in a planar different layers. Okay, since they are in planar different layers, okay, one layer can be rubbed over the another layer. That is why it is called as what? Slippery. The boric acid is slippery since it has planar layer structure. Okay, I hope you are able to understand. Okay, all the boric acid molecules will be held together by which bond? The boric acid molecules are held together by hydrogen bonds. Hydrogen bonds. Okay, so what is the structure of boric acid? It's a planar, okay, layered structure like graphite, and therefore it is slippery. Slippery. Okay, so students, so that's all about boric acid. Now we will go with the last compound of boron. Okay, yes, which is the last compound of boron? The last compound of boron is, yes, the last compound of boron is a very, very important compound. Okay, a very, very, very important compound. What is it? Okay, that is called as diborane. Okay, the last compound, that is diborane. Diborane. Okay, what is the molecular formula of diborane? The molecular formula of diborane is B2H6. Okay, what is the molecular formula of diborane? It is B2H6, isn't it? Okay, actually, okay, diborane, borane, BH3, BH3. This is called as borane. Borane. Okay, it is actually unstable. It does not exist. Okay, therefore, okay, it exists in the form of B2H6. This will undergo dimerization. This molecule will undergo what? Dimerization to form this molecule. Okay, yes, this molecule will undergo dimerization to form this molecule, because this molecule is highly unstable, it does not exist. Okay, it will undergo dimerization to form this B2H6. What is this molecule called as? Borane. BH3 is called as borane. Okay, if two molecules of BH3 combine, they form what? B2H6. And what is this molecule called as? This molecule is called as yeah, the molecule is called as diborane. Diborane. Understood? Okay, so how to prepare boranes? Preparation of boranes, very important. Okay, preparations of borane. preparations of borane. Okay, please try to understand this. Preparations of borane. Okay, yes, how do we prepare borane? Okay, well, no, well, we will understand both laboratory method, okay, laboratory method and industrial method. Okay, so both of them are there in your NCERT textbook, so please understand both laboratory method as well as what, industrial method. Okay, so if I talk about laboratory method, look here, very simple. When boron trihalides like boron trichloride, okay, when boron trichloride is treated with lithium aluminium hydride, LiAlH4, okay, LiAlH4, lithium aluminium hydride, it's a powerful reducing agent. Okay, lithium aluminium hydride is a powerful, yeah, what is it? It's a powerful reducing agent. Okay, so how do you write the product here? How to write the product? Observe the products formed here. Okay, so there is lithium and chlorine. Lithium will combine with chlorine to form what? Lithium chloride. Okay, and then aluminium will combine with chlorine. Aluminium will combine with chlorine to form what? Aluminium chloride, AlCl3. So what else is left? Boron combines with hydrogen to form what? Yeah, borane, BH3, correct? Okay, boron combines with hydrogen to form borane. Lithium combines with chlorine to form lithium chloride. Aluminium combines with chlorine to form aluminium chloride. Boron combines with hydrogen to form what? Borane. We know this is unstable. Okay, two molecules of borane will combine to form what? Diborane. Understood? There is one more method of preparation. Yeah, there is one more method of preparation. Okay, what is the other method of preparation? We will take NaBH4, sodium borohydride. Okay, NaBH4, what is this? Sodium borohydride. Okay, when sodium borohydride is treated with iodine, okay, yes, very important reaction. Okay, many times the question has been asked on this question. Okay, yes, many times the question has been asked on this reaction. Okay, sodium borohydride is treated with iodine. Treated with what? Iodine. Okay, again, sodium borohydride is a powerful reducing agent. Okay, yes, sodium borohydride is a powerful, okay, reducing agent. Okay, reducing agent. Now sodium is there, iodine is there. Sodium is there, iodine is there. So what is the product formed? It will form sodium iodide, correct? Okay, sodium and iodine will combine to form what? Sodium iodide, and obviously the product is BH3, and along with BH3 hydrogen gas will be liberated. Along with BH3, which gas is liberated? Hydrogen gas is liberated. Okay, these two are the laboratory methods of preparation of borane. Okay, what are the different methods of preparation of borane? When boron trichloride is treated with lithium aluminium hydride, we will get borane, lithium chloride and aluminium chloride. The next method is when, okay, yeah, sodium borohydride is treated with iodine. When sodium borohydride is treated with iodine, it will form sodium iodide, okay, borane and hydrogen. What is the other? That is the industrial method of preparation of borane. That is very simple. So you take trihalides, okay, treat it with what? Okay, yeah, sodium hydride. Okay, take trihalides of boron, okay, treat it with sodium hydride. Sodium combines with chlorine to form, yeah, sodium combines with chlorine to form sodium chloride, okay, and when you treat boron combines with hydrogen to form what? Borane, BH3. Are we clear? Understood? Okay, so take three molecules, we will get 3 molecules of sodium chloride and borane. Are we clear? This is the industrial method of preparation of borane. Okay, any doubts? So when trihalides of boron, okay, is treated with sodium hydride, okay, hydrides, we will get boranes and, okay, sodium chloride, borane and sodium chloride. Any doubts? So these are the different methods of preparation of borane. Now let us see why, okay, let us see why, okay, and how borane will dimerize to form what? Diborane. Okay, let us see why and how borane will undergo dimerization to form diborane, and what is the structure, very important structure. Let us understand the structure of diborane. Understood? Okay, see, okay, see students, in my very beginning videos, okay, I have told you that, okay, yes, elements of boron family, elements of boron family, elements of boron family, okay, yes, will try to satisfy, okay, their electron deficiency, satisfy their electron deficiency, okay, in their compounds, by two methods, isn't it? By two methods, yeah, okay. So elements of boron family, okay, will try to satisfy their electron deficiency in their compounds by two methods. What is that method? The first method is called as back bonding, okay, and the other method is called as dimerization, isn't it? The other method is called as what? Dimerization, isn't it? Correct? Okay, just like I explained, I have explained back bonding in case of what? Boron trifluoride, like this. Look here, okay, yes, boron trifluoride, is that correct? Okay, yes. So in boron trifluoride, what is the hybridization of boron? Okay, yeah, boron is, come on, sp2 hybridized, isn't it? Boron is sp2 hybridized, okay, and boron consists of one vacant, okay, 2p orbital, okay, boron consists of one vacant 2p orbital. Now there are lone pair of electrons, okay, in 2p orbitals of fluorine. Okay, that now this is vacant 2p orbital. There are lone pair of electrons in the 2p orbitals of fluorine. Okay, we know 2p orbital, they have same energy. Okay, if the orbitals have same energy, then the extent of overlapping will be, okay, very high. Correct? Okay, in chemical bonding we have learned. Okay, now in chemical bonding we have learned that, okay, now bond is formed, a covalent bond is formed by the overlapping of atomic orbitals, isn't it? Okay, if the energy of the, okay, combining, if the energy of the overlapping orbitals is same, then the overlapping will be maximum. Okay, if the overlapping is maximum, okay, then the strength of the bond is going to be strong. Okay, it's going to be high, the bond is going to be a strong bond. If overlapping is more, the bond is going to be a strong bond. Okay, so here, so there is vacant 2p orbital of boron, and there are lone pair of electrons in 2p orbital of fluorine. We know 2p orbital will have same energy. Okay, since they have same energy, the extent of overlapping, okay, will be more. Hence, okay, I can say that fluorine will transfer its lone pair of electrons to the vacant orbital of boron. Correct? Fluorine will transfer its lone pair of electrons to the vacant orbitals of boron. When fluorine transfer its lone pair of electrons to the vacant orbital of boron, it is going to form a coordinate bond. It will form a coordinate bond. Okay? Yes. So I can write it like this. It forms a coordinate bond with boron. Okay? Fluorine transfer its lone pair of electrons to the vacant 2p orbitals of boron, and it forms a coordinate bond. Well, this is called as back bonding. Okay, this is called as what? Back bonding. Okay, when fluorine donates its lone pair of electrons to the vacant 2p orbital of boron and forms a coordinate bond. Now count the number of electrons around boron. Okay, how many electron pairs are there around boron? 1, 2, 3, 4, 5, 6, 7, 8. Okay, don't you think the octet structure of boron is complete? Yes. Okay, look at here, the electron deficiency of boron is reduced, okay, when, okay, fluorine transfer its lone pair of electrons to the vacant orbital of boron, and that process is called as what? Back bonding. Understood? So like this, the elements of boron family will try to reduce their electron deficiency, okay, in all their compounds, either by two techniques. One is called as back bonding and the other one is called as what? Dimerization. Now coming on to boron, okay, boranes, BH3. Look at here, B, okay, H3, BH3. Are you getting my point? BH3. Okay, see here also, okay, so there will be vacant orbital of boron, okay, there will be vacant 2p orbital of boron, okay, are you getting my point? Now just check the number of electrons around boron, okay, yes, 1 2 3 4, okay, 5 6, 1, okay, 1 2 3 4 5 6, there are 6 electrons around boron. There are 6 electrons around boron. It is deficient of 2 electrons to complete its octet. Therefore, boron is electron deficient, isn't it? Boron is electron deficient. Now, can hydrogen form back bonding with boron? Can hydrogen satisfy the deficiency of electrons of boron? Okay, can hydrogen satisfy the electron deficiency of boron through back bonding? No, hydrogen cannot satisfy the electron deficiency of boron through back bonding, because hydrogen does not have lone pair of electrons. Okay, just like fluorine, okay, just now the what we have seen in case of fluorine, it is not happening in case of what? Hydrogen. Fluorine had lone pair of electrons, therefore it was, it was able, okay, to transfer its lone pair of electrons to the vacant 2p orbital of boron. But here there are no lone pair of electrons on hydrogen. Since there are no lone pair of electrons on hydrogen, okay, hydrogen, okay, cannot satisfy the electron deficiency of boron, then boron is going to be electron deficient. Then what is the other way? What is the other way to satisfy the electron deficiency of boron? The only way to satisfy the electron deficiency of boron is going to be by what? Dimerization. It's going to be dimerization. So therefore, in boranes or in diboranes, there will be no back bonding. Okay, yes, what is it? Okay, it is only dimerization. Dimerization is going to take place, okay, in case of borane. BH3, okay, will dimerize with BH3 to form what? B2H6. When it dimerizes, the electron deficiency of boron will be reduced. Okay, what is this process? It is the process of dimerization, not through back bonding. Why back bonding is not possible in case of borane? Because hydrogen does not have lone pair of electrons. Okay, now clear? Let us understand the dimerization of boranes to form diborane. Okay, let us understand the dimerization of borane to form diboranes. Look here. Okay, see in, okay, yeah, okay, see this is one boron, okay, one borane, BH3, isn't it? BH3, okay, BH3, correct? Yes. Okay, look here, in borane, this is one BH3, okay, this is another BH3, okay, this is another BH3. Are you getting my point? Okay, see in boranes, the boron atom is sp3 hybridized. So this is sp3 hybridized, this is also sp3 hybridized. Okay, so here boron, okay, yes, there will be bond now, okay, yes, okay, this hydrogen will try to form bond with this boron, and this hydrogen will try to form with this boron. Okay, so the entire molecule is called as what? B2H6, isn't it? Okay, this process is called as what? Dimerization. Okay, the whole process is called as dimerization. Now let us understand very important, okay, very important, what is it? Okay, the structure of diborane. Okay, what is the structure of diborane? Look here. Okay, very important. Okay, what is the structure of diborane? Okay, I told you in diborane or in borane, okay, boron is sp3 hybridized, correct? Okay, what type of hybridized is it? Okay, boron is sp3 hybridized. Okay, in diborane each boron atoms are sp3 hybridized. Okay, see now it is a very important structure. We call the structure of diborane as, okay, three centered 2 electron system. 3 centered 2 electron system. This structure is called as 3 centered 2 electron system. Okay, what is this structure called as? This structure is called as 3 centered 2 electron system. Okay, so I told you in diborane each boron atoms are, okay, sp3 hybridized. Okay, so there are 2 boron atoms, understand, there are 2 boron atoms. Okay, so each boron is sp3 hybridized. Upon sp3 hybridization, okay, how many hybrid orbitals are formed? 4 hybrid orbitals are formed, isn't it? Okay, yes, so 4 hybrid orbitals are formed like this, is that correct? Okay, so this is going to form 4 hybrid orbitals just like this. Okay, yes, okay, yes, correct, 4 hybrid orbitals are formed. Out of 4 hybrid orbitals, 3 hybrid orbitals, okay, 3 hybrid orbitals will overlap with 1 s orbital of hydrogen like this. Out of 4 hybrid orbitals, okay, 3 hybrid orbitals will overlap with what? 1s orbital of hydrogen like this. Look at here. Yeah, are you getting my point? So there will be 2 electrons here, okay, 2 electrons here and 2 electrons here, correct? Okay, yes, so out of 4 hybrid orbitals, 1 2 3 4, out of 4 hybrid orbitals, 3 hybrid orbitals will overlap with 1s orbital of hydrogen. Okay, the same thing happens here also. Out of 4 hybrid orbitals, 3 hybrid orbitals will overlap with 1s orbital of hydrogen, 1s orbital of hydrogen, 1s orbital of hydrogen, correct? Okay, now this is vacant orbital of boron, this is vacant orbital of this boron. What is going to happen? Okay, see, these electrons momentarily try to drift from here to here. Okay, yes, look here. Okay, these electrons, okay, these electrons will momentarily drift from here to here. On the same lines, these electrons will momentarily try to drift from here to here. Are you getting my point? There are 2 electrons here, there are 2 electrons here. So these electrons will drift from this orbital to this orbital, and these electrons will drift from this orbital to this vacant orbital. That means these 2 electrons, okay, no, is shared by boron, hydrogen and boron. On the same lines, these two electrons are shared by boron, hydrogen and boron. Am I correct? Boron, hydrogen and boron, isn't it? Okay, are you getting my point? Okay, so these electrons will drift from, okay, from here to this vacant orbital, and these electrons will drift from here to this vacant orbital. Okay, yes, therefore these 2 electrons belongs to both the boron, and also these 2 electrons belongs to both the boron. Okay, look here, why is this called as 3 centered 2 electron system? I told you these 2 electrons belongs to boron, hydrogen as well as boron. These 2 electrons belongs to boron, hydrogen as well as boron, isn't it? So 3 centered, boron, hydrogen, boron, boron, hydrogen, boron, 3 centered, 2 electrons. 2 electrons belong to 3 atoms. 2 electrons belongs to 3 atoms. That is why it is called as 3 centered 2 electron system. Okay, what is it called as? 3 centered. 1 2 3, 2 electrons. 1 2 3, 2 electrons. 2 electrons is shared between 3 atoms. 2 electrons are shared between 3 atoms. That is why it is called as, okay, 3 centered 2 electron system. Okay, and what is this bond called as? Yeah, this bond is called as a special bond. This bond is called as what? Yeah, this bond is a special type of bond. And what is this bond called as? Okay, it is called as banana bond. Okay, what is this bond called as? Yeah, this is called as banana bond. Okay, yes. Now, and understand one more thing here. Okay, see these, there is one hydrogen here, there is one hydrogen, isn't it? Okay, see these 1 2, okay, yes, 3, 4. These hydrogens are called as terminal hydrogens, whereas this hydrogen and this hydrogen, they are called as bridged hydrogens. 1, 2, 3, 4. These are called as terminal hydrogens, whereas these two hydrogens are called as what? Bridged hydrogens. See, one boron, this boron, this boron, this hydrogen, this hydrogen, this hydrogen, and this hydrogen, they all will lie in one plane, whereas this hydrogen will be above the plane and this hydrogen is going to be below the plane. Are you getting my point? Boron, boron. Okay, see these four, okay, yes, these, all this will lie in one plane. It is something like this. Look here, yes, BH3, isn't it? Okay, so this is like this. See this, okay, these things, 2 borons and the 4 hydrogen atoms will lie in one plane. This hydrogen will be above the plane, this hydrogen is going to be below the plane. It's a non-planar structure. Okay, it is a non-planar structure. Why it is a non-planar structure? It is because of what? sp3 hybridization. If it is sp3 hybridization, what is the structure? It's going to be tetrahedral here and tetrahedral here. Okay, so students, so that's all about diborane. In the next video, we will be starting with the next family, that is called as carbon family. Okay.